Okay guys, so we will continue our class today. Before we start, right, I just want to share few things what I added today. Okay, so just look at that GitHub. In our JavaScript, go to your revision, JS revision, right? And if you look at the advanced topic, when there is first class citizen, higher order function, callback function, right? So function declaration, function expression, and function statement, right? These are the things I have not added. So we know already this one, okay? How to declare function, how to write expression function, and how to write a function statement. So declaration and statement is same, right? Same thing. Okay? So now if you go down all the way to the bottom, right? I mean, this is the execution context. We can talk about that. Lexical environment, we'll talk about that. You can read all this, right? Points to be noted, you know, the important things, right, during the, I mean, in the execution context and what happened over there. Okay, so we will talk about all this right now. So what is closure, what is first class function, callback function, right? These are the definitions you should remember. Okay, so first class function, callback function, closures, and all related to the execution. I mean, all now start from the execution context, right? I mean, there are functions, and when the function execute, things happen. Okay, only after that things happen, right? So let's go to the code. Okay, first code, right? I have the new file script3.js here. Okay, in this new file I just added console log start, then there is a variable, there is a console log c and console log end, right? If this code starts, right, what can happen now? Let's say we just execute this code. Okay, let's go back and check in our live view. So let's look at the console, right? Okay, so we have start, and then there is console log 30, right? Console log c and then end. Okay, so if you go to the source code and look at your this script.3, right? And let's say we pause here. Okay, maybe pause in one of the place. Okay, pause in these two places, right? We just make a pause. So the when the code start in JavaScript, when the code start, what happens now? Anyone, can you tell me what happens first and foremost, right? What happened when code start? Let's say you just run the code, right? Your code started. Okay, what it will come in your mind, you know? Can you think of anyone? Just think, right? Just think, if the code runs, right, what happened now? Just imagine. Okay, what happened now when the code runs? What should happen in the behind the scene, right, in the engine? No one want to? Mohammed, you want to answer? Look like it's freeze, right? Something happened to the network. Hello, can you hear me, guys?
I can hear you.
Okay.
Not sure if I understand the question.
No, the question is, right, when JavaScript file run, okay, when you run the JavaScript file, basically when you load the JavaScript, right, what happened in the JavaScript engine in the first phase, right? What does it happen? Means how the code start executing. Let's say JavaScript, you have a JavaScript file, right, and it loaded to your page, correct? When you run the HTML index page, JavaScript file is connected there, and it will run, right? JavaScript file will execute something, the line of code, you know. But in the beginning phase, what happens? That's the question, right? Exactly what you can think of,
It'll run in the global state or the local, in the global variable or the local variable, depending on how you place the code.
Okay, so in the code, right, in JavaScript code, what is there? Can you what we can place, what kind of code we can place? Can you tell me what we can place there? Let's say imagine you are writing a JavaScript code. What might be there, right? What might be there?
Functions.
Function. Okay, one is function. Next, what you can add? Not in the normal basis, right? You can have function. You maybe have variable, right? Variable, correct? To store some data or something. Either function or maybe variable. That's it, right? Normally, you're not gonna have loop, for loop, or conditions there. That will, most of the time it will come inside the function. But even if you add loops, right, it's okay. There will be a for loop and you have there, right, in the code. Okay, so now there is a function and there is a variable, right? Function and variable inside your page. So let's imagine this is our page, right? This is a page. Okay, this is our page. We have just, this log is also a function. This is just a function, right? So the first phase, the first thing what happens, right? JavaScript engine will scan the whole page. Okay, it will just scan it, right? And it will create the execution context. What it will do? It will create execution context, and that is called global execution context. Okay. So first, what it will do? It will create global execution context, right? Let's imagine execution context is a box, right? Box. Okay, this is a global execution context. Fine, we got this one done, right? So when JavaScript engine will scan the whole page, in global execution context, what it gonna do? It will add all that, right? If there is a variable in our code, right? What we have now? Let's look at this example. We have one variable and nothing else, right? Nothing else. These are just the, it's just creating the execution context, right? So in every execution context, there is two things, okay? The memory and the code, right? Code. So in memory, it will just add C, right? And it will be undefined, but let's say we have the value 30 right now. That's it. The first time it will create what? Global execution context. This will be pushed to the call stack, right? Call stack. How code run in JavaScript engine? Inside the call stack only, inside here only, right? So soon the page load, it will create this global execution context. It will scan the whole page and create memory for everything. Everything means what? Variable and the function. That's it. Function, right? So I don't have function right now. It's just a variable. And after creating the memory, basically this will be pushed inside here, right? So let's say this is our global execution context. Okay, that is just the short, the expanded form, right? So now the code will run here. The first line of code is what? Start, console log start, right? So it will just, in the console is what? The API of the browser, right? It will call console and then print there 30, whatever in the variable C, right? 30. It will just get value from its local memory. So whatever here, right? If this variable is used inside here, then that is local memory for this execution context. Local memory, right? This C is local to this one. So it will print 30. Next is what? Basically, see how code run, right? This 30 I put earlier, but it should be undefined. Then code start running. It will print this. It will print start. Then it will assign 30 to this variable, then it will console log 30. So C is local, right now local to this global execution context, so it prints 30, right, and then console log end, so it will print end also, end. Okay, so start 30 and end. Okay, clear? Okay, fine. Now let's improve this, right? Let's improve this. So what I'm gonna do now, in the global I'm gonna add a function, right? Call it x, function x. Okay, so one more thing, right, before we keep moving forward, I want to bring some word here, scope, right? Scope. So what is scope now, right? Scope basically is where you can access the variable or function, right? Where you can access the variable and function. Okay, scope. So if I say what is the scope of 30, right? What is the scope of 30 now? I mean C. What is the scope of C? So C is right now in global, right? Global execution box. So you can access C in the global, because C is local memory for the global execution context. Clear? So you can access C here. So we will find out, right, what are the more scope of that C later on. Okay, so let's move here now. So I have let a equal to 12. Okay, and then I'm gonna have another function, right? Or maybe let's do one thing, console log C, right? I can do C, simple. So let's say this file run, right? This file run, what's gonna happen now? In the global execution context, yeah, one more thing, we have to execute this function, okay, x, right? So let's look at this code now. Let's go and understand this. So when you have x, function x here now, remember when the code run, what's gonna happen? It will look for the variable, all the variable and the function. Basically in the global, first you only worry about this global. Okay, so we have a C already. Let's say we rerun, right? Rerun. We understand the C. Now we have function also, right? Function here. So function equal to basically the whole definition of the function, right? Will be here. Okay. Function. That function is what? A, right? Function is x. So this is function x. Just imagine this is function x. Okay. So now code run. When code run, what's gonna happen? It will start from the top to bottom. Okay. Start this line. It will print start. Then it will assign 30 to C. Then it will print C. Right, then this is just in the memory, nothing gonna happen. You always look for the function execution. Okay, so function execution, that is important, right? So what happened when the function execute? What happened, right, when function execute? Basically function execution context is created. So what is function execution context? It's similar to global execution context. So execution context is nothing but the box, right, where the code execute, but it has two parts now, right? Every time when the function executes, it will create execution context. Okay, so let's look at that one now. So the code start running, right? There was a console log start, then the memory assign, value assigned to C, then the console log C, we print that 30 here, then in not in, but before that, right, we have function x is executed, correct? So when this function execute, it will create separate execution context. Let's create here itself, right? So every time when function execute, what is gonna happen? It will create execution context. So now here just imagine this function will be pushed, right? So x function will be pushed to the call stack. Okay, so that is x, right? So let's say this is what this is the code to execute, and this is a memory. So the process is same, you know, every time when the execution context is created, when the function execution context is created, that is just a box, and it has two parts, memory and code execution. It will scan that function, everything it will scan first and add the variable and function to the memory. Okay, so go back and look at our function now, right? So we have let a equal to 12 and console log c, right? C. So we're gonna have one variable called a, right? So that is a. Right now is undefined, right? And then we have nothing else. We have anything? No. Console log c, right? That's it. So console log will not do anything in the memory, right? But now code start running here. So a will be assigned a value, right? 12, and the console log c now. Console log c. Okay, now it's time to understand, right? Let's say this is function x. So here in the x, right, this is the, let's say this is the environment, okay, environment, or maybe some kind of chart, right, some kind of record, okay, that is called lexical environment, right? Lexical environment or lexical scope, okay, lexical scope. So what is lexical scope now? If I say what is lexical scope, so the lexical scope equal to, right, let's write it here quickly. So lexical, right, lexical scope is equal to local memory plus parent lexical memory, right? Parent lexical scope, lexical environment or lexical scope, right? So parent lexical scope, let's call it parent lexical scope. So lexical, see, the lexical scope equal to local memory, right? So wherever the lexical, whenever the function executes, it creates the lexical scope. So it keeps the record of local memory plus parent lexical scope. So again, parent gonna have a lexical scope. So that lexical scope is same thing, right? The local memory of the parent plus the lexical scope its parent, right? So in case of global can have what? Lexical scope, right? So it can have local memory plus the lexical scope of global is null, okay? That is null, right? Null. There is no parent for global, so that is null, okay? But local memory is there. What is that? C, right? You have C, and also you have function there in your lexical memory. Clear? So because X has access to the parent lexical environment or lexical scope, right? Lexical scope, you know, it can easily find now, right, the value of C. See that C. So first it will look for C inside its local memory. It will not find. Then it will move to the lexical scope, right? Lexical scope, where the lexical scope is what? The access to the parent, right? So parent is global right now, and there it will find that C. So that is the lexical scope, right? So if I ask again, what is the scope of the C? Because C is in the global memory or global scope, right? Any child of the global scope has access to this. Clear on that? Means any child, right? So if I create another function here, let's say inside the X now, right? Inside the X I will create another function. Let's call it function Y, right? Y. And we can go, let b equal to maybe 20. Just create one variable, and then we can have console log log C again, right? C or maybe even A, whatever. You can see console log C, console.log A, you know, you can do that. It's okay. You can console log B, whatever in the local, right? You can do that. Console.log B. Okay. So look at this code now, right? So Y is there. So you have to execute Y. Okay, Y, right? Y. Simple enough. So we are inside X function. We have the first will be variable A, console log C, and then there is another function, right? Okay. So this function Y executes inside A, right? So now let's improve this. So you have now a variable, right? And then you have function again. So this function will be added to the memory, right? Function. That is Y, okay? Y function. Clear? Y. So when Y function execute, when the code start running, right? I mean, it will assign 12, then console log C, and then Y execute. Y function execute. So when this Y execute, what happened now? What can happen, right? So when every time function execute, it will create complete new execution context. So this is Y now, right? Y. Okay. And that will post in the call stack. Y. So Y gonna have also lexical environment. And this lexical environment is what? The local memory of Y and the lexical environment of its parent, right? Or lexical scope, okay, of its parent. So local memory plus lexical scope of the parent. That is lexical scope. Okay. So now Y has what? Y has a, let's say in Y, right? Memory creation and the code execution. So memory will be created. So it has, let's see, B, right? There is a B. So that's it. B will be equal to 20, right? I mean, when code start running, it will add 20 here. Then it will run console log C. It will try to find C in the locally. It will not find. Then it will go to the lexical parent, right? Lexical parent. You can call it Y is lexically inside X. That is also you can call, right? But let's say it will look for the lexical environment of the parent. So lexical is who? X. So it will look in that one. It's not gonna find, right? So it will again move to the next one now, up lexically to the X parent, okay? And that is global C, right? And it will find there. So that's the lexical scope. So lexical scope is nothing but the area, right, which keeps track of the local memory plus the parent lexical environment or lexical scope. Clear now on that lexical scope, guys? Everyone? Okay, so that is the lexical scope, right? So there is a lexical scope chain. Scope chain is same thing now. It forms like a chain, right? Same concept, you know. So if they ask you what is scope chain now, right? So you have to, you know, just create simple example and show it, right? Or unless you can find some definition online, scope chain. So scope chain is nothing but the, let's say, when right, the child creates the lexical scope. So it has access to its parent lexical scope, and parent has access to its parent lexical scopes. So they create chain-like structure. They create chain-like structure, right? So that is what we call scope chain. It's because they are all connected, you know, like chain, right? So the inner child can access to the parent lexical environment. So that's why something in the global can have access to all its children function, right? Okay, so that was the lexical. If that is clear on, so we're gonna move on, right? Let's see. Anyone has any doubt now on lexical scope? Lexical, what do you call that? Scope chain and lexical environment, or lexical. God, I get mixed up, right? So lexical environment. Let's call it lexical environment. Okay. Anyone, just tell me. Okay, I will give you 30 seconds to think, right? Tell me, guys. I hope that means it's clear, right? On that part. I mean, it's, if you just think it's, you know, you just look at the function, right? The function, then you're adding another function inside, right? If there is another function inside again, that means that function is linked to the parent lexical environment, you know, and that's why it has access to all these what do you call that, variables and functions, right? Whatever there, it has access. Okay, so let's look at that same code, right? And we're going to talk about the closure also. So how the closure is formed now, right? How closure is formed. Okay, so let's try to understand. So I will refresh this page. Okay, and we added a lot of things now, right? So I will remove this. So let's say in here, right, line 12, we have in y, function y, we're gonna add this, just stop here, right? Let's put it here and then run this code. Okay, so we have pause, you know, we have pause. I mean, everything run, right? We just have pause inside the console log C and A. So when the y execute, right? Y execute. Remember that we are in the y right now. This is the global execution context. Anonymous is global execution context. Then the function x is there inside the call stack, and the y is there, right? But we just pause it, so it did not complete. Okay, we pause. So what is closure now, right? What is closure? Because once we understand lexical scope, it's just easy to understand closure. Okay, so what is closure? So let's look at the definition of closure, right? Closure. Okay, so if I just put the definition here, a closure is the combination of a function, right, bundled together or enclosed with reference to its surrounding state, the lexical environment. In other words, a closure gives you access to an outer function scope from an inner function. In JavaScript, closures are created every time a function is created, at a function creation time, right? See, so that definition should be clear. I mean, in other words, see this line, right? In other words, closure gives you access to an outer function scope, means outer function scope, right? So in our case, y is inside, so y has access to its outer function scope like x, and also from the global, right? See, so that is closure. It forms closure, and that closure makes possible. And the closure is forming. How closure is forming? Because of the lexical environment. Okay, so closure is nothing but the function, this function y, right, enclosed with its outer lexical environment with x or maybe global, right? So let's look at here now. See, the we are in y function, right? So y function y has formed the closure with x function x. So closure function x, right? X. So look at this. X is just accessing the a, right? A here. See? So from x it has access to a. Okay? That's the closure. And even in the script, what is that? You can see C also, right? Global. Okay? So that is in the global already. But there is a closure right now, x. So closure, how closure is formed? The function y, let's say the function y makes a closure with its outer function, so that it can access, right, its variables and functions. Okay, so you can look at this definition and remember it, right? Just, you know, try to read couple of times and try to understand that. But you can, looking at this code here, it will give you some idea what is closure. And they, in JavaScript interview, they're gonna ask you, right? Mostly they ask what is closure, right? Can you explain closure? So you can simply add maybe one function here, add couple of variable, and then see a y, and then just, you know, pause it here and then look at, right, the closure is formed. So you can say function y forms a closure with function x because of and why the closure is formed? Because of the lexical scope. Lexical scope, right? So we understand lexical scope means you can understand closure. So closure is nothing, it's just the like term, right? Just remember this term is, you know, when you understand the lexical scope, that means y has access to the lexical environment of x and its parent, right? That is right now global. So again, what is lexical scope? So lexical scope is the local memory plus the parent lexical environment. The same thing goes to the parent, right? Its local memory plus its parent lexical environment. So it's like a chain now, right? So that is scope, scope chain, and lexical environment. They all are connected to each other. So we understand scope also now. Scope. What is that? Closure here. So if you read this definition, that will be good enough. It's combine the function, right? Bundled together or enclosed with reference to its surrounding state. The lexical environment, okay? So you must know what is the lexical environment, right? Local memory plus the parent lexical environment. Okay. So first class function, what is first class function, guys? Anyone? First class function. Why we call first class function? So function, right? Let's say, let's go back and try to. So if right, if I go back and create one simple function here, function, right? Let's say z, okay, and it has console log something, right? Console.log. Maybe no, not x, but let's call it z. Last function, okay, something it will print, right? So this is one function. If you can pass this function, right, you can pass this function as a value, because you can pass the function as a value to another function straight, you know. So if this is a function x, right, you can pass it here also, you can pass here, you know, simply like this. See that? And then in the function x, you have to receive it, right? Let's call it z here itself. So when you pass any value to the function call, you have to receive that. So that is this is the parameter and this is the argument. The value is argument and here is a parameter. Okay. So now I can call this function straight somewhere, right? If I call this g here, you know, and because that is function, I can execute. So that's why in JavaScript you call the function like a first class citizen, because you can even pass the whole function as a value to another function. Okay, that's the reason, right? First class citizen. So if we run the code now, let's run, right? Oh, I have to refresh, guys. So let's go back and see. If you go here, function last, right? See that? last function. It's already printed. Okay, so we have the end here, but you saw that, right? That just print data inside our function x here. Okay, clear on the first class citizen, why function is first class citizen? That's a simple definition. Yeah, you can pass the function like a value to another function. That is what, right? The first class citizen. Okay, so what is next now? What is callback function now? Callback function, right? It's same thing, callback function also, right? So a function, because that's the definition, first class function, that we call it first class function. So there is more thing, you know, you can even assign the function, right? When you return function, like you know, let's say in here, right, this y function, I don't have to execute, I can just return it, return y, you know, simply like this. Because function is first class citizen, right? In JavaScript you can even return the whole function. Okay, and so let me put this somewhere on the top, because once you return it will terminate, right? So you can leave it here somewhere. So you can return this also. Okay, when you return, right, so when this function execute, you can even grab that. So let's say let y equal to something. So when this run, you're gonna get this return function y, right? So let's console log here, right? Console.log y and see what we get. Okay, so see, we got the whole function, right? Y function. So when you have function like this, you can execute, correct? So you can, so let's check now, right? Even I can put here anything, you know, let's say answer, right? I just store in the variable answer. And what we can do, let me execute answer, right? Answer. Okay, answer. So see, this function is already outside now, right? It does not know anything inside here. It's just outside, away, far away from this, right? The whole thing, this function x. See, you are executing something outside in global, but still it will do all the job, right? And why is that? Because of the, see, it just did everything, right? Clear? So it print 30, 20, all that. Why? So if I pause here, let's say I pause here, right, and run this, look at here, it still creates the closure. It still creates the closure, right? Closure. Or I should have do one thing, you know, what I should have done, right? Okay, let me pause here and then check. Okay, so run this code. So answer is undefined right now, right? That's okay. So in call stack right now, this is paused, so it did not create the, the x did not move yet. Okay, in the call stack, and it is waiting now, right? So if I click the button here, see, now they move, right? The x move already inside the, what is that? Oh, it's still not right there. So let's create now. X just executed, right? So it has not moved to the call stack. So let's, because right now we only have this function, you know, we have this function which is in the global executing. Okay, this function has to execute in order for x to go inside. So let's move. What happened? Okay, so we have closure now x, there is a y, run again. So y is running now, right, one by one. So y is still running there. It assign all the value to the b, c. So, okay, so it's done now, right? Where is x now? What happened to x? End. That is console log end. Okay, let's refresh one time. I want to see the x, you know. So answer, here we are just executing x, function x, right, to the answer. Okay, so answer is just a variable. Okay, let's run, right? Let's run this one more time and see what happened. Okay. Okay, so we have the let variable, right? So this whole x is just like a value. Okay, right now is undefined, and soon we run one more time, it will get the whole answer, right, to the answer here. So it just get everything here. See that answer get what now? The function y, right? That's it, because answer is returning the x, the function x is returning y. Okay, and that is what we get in the value, answer value, right? That is what we get. That's why you don't see anything here, right? Because unless I stop here, you know, unless I stop, make a stop sign in the x variable, a equal to 12, and then you might find the x inside the call stack. But it is just getting the whole answer to the answer variable and done. Right now you can see answer variable has function y, and that is what it return. Okay, and you know, once you run again, right, it will execute this part and then it will print everything. So I mean, that is what happening in the y. Okay, line by line, right, printing c, a, and then b, and then it will finish, right? It will finish everything. Okay guys, so we understand the callback function and first class function. So callback function is what? When the function you pass, right, to another function as an argument. Okay, argument. So argument is like a value which then invoked inside the outer function, right, to complete some kind of routine action. Okay, so remember we have the also higher order function, right? So what is higher order function now? Okay, let's go back and write down. Remember we have map, right? Map is a higher order function. Okay, because when you loop through the array, right, you have array like this with some data here. Let's take simple example, you know, and then you're gonna put dot, because array is an object, right? It's the array is an object or our data type. Dot map. Map is a higher order function because it takes another function as an argument, and this function, right, is called callback function. Okay, so I just put arrow function here. So arrow function, right, and if you console dot log something, let's say x, and that will, this x is coming from this parameter now, parameter of the callback function. Okay, so what happened here now, right? Just remember map is a higher order function because it takes another function as an argument. So any function which takes argument as a function, then the first one is higher order function, this is callback function, right? So this callback function will take action and do certain things, right? A routine job, you know, it will do. Means map is a loop, so basically it will loop through this array. Every time it's gonna get each item or each element of the array, and you do whatever you want here, right? So it will just loop round going through this array. So higher order function, callback function, that's callback. Okay, so now, right, now is so we understand higher order function, first class function, and callback function, right? All that you understand. Closure, you understand execution context, that is when the function execute, it will create the box. It has two parts, memory and what else, code execution. Okay, all that. So just read through, right, make a note, simple note, try to understand, and then please repeat couple of days until you understand. Okay, all right, so we're done with this part now, right? We're gonna we're going to look at something called let's say, yeah, remember what I said yesterday? I did not put here, right? Event loop. Okay, event loop. So let's go to the event loop now. So I will close this. And start new file here. So I just prepare before I started, right? Little bit, just create file and all that. So just to make it little, even 1 minute's time saving, right? Event.js. So event loop now, right? Event loop. What is event loop now? Event loop. So in JavaScript engine, right, there is a functionality called event loop. Okay, so what is the job of event loop? What is the, I'm just writing myself, right, what I understand. Okay, what is the job of event loop? Just in the normal way to understand, right? So event loop, okay, what it does, right? Constantly, right? I mean, on the regular basis, regularly or all the time, right? So event loop constantly monitor call stack, right? And what else? And right, I think there is something. Okay, I make a note. Remember, I forgot, right? So I always forget things. So that is called call stack queue. Call stack queue, right? Q-U-E-U-E-Q, I think, yeah. And there is micro task queue also, right? So we're going to talk about all this right now. Micro task queue. Okay. So event loop is basically the functionality in the JavaScript engine, right? The job of event loop is to monitor call stack, because we have only one call stack in our JavaScript, correct? And inside that call stack, every code executes step by step, right? So if you have thousands line of code here, right? Let's say you have console log start, right? Start, okay? You have something start. So when the code execute, this line will be first one to go, okay? And then you have console log in, right? Console.log in. So that will be the last line to go, right? But maybe inside here you have thousands of line of code, thousands and millions of line of code, right? So it will go line by line, from top to bottom. It will be go line by line from top to bottom, right? It will not jump from line 4 or maybe 20 or 100. No, it will start from top and it will go all the way down. So that's why JavaScript is called single-threaded programming language, right? Means it has one call stack and the execution context will be executed step by step. So if you have many functions, right? Let's say you have function here, A maybe like this, B, C, right? So it will print this one, then it will print this function, then it will do this job, okay? Step by step. Fine. That is the job of, that's how the JavaScript works. That is because JavaScript is a synchronous, right? Synchronous single-threaded programming language. Synchronous. Okay, synchronous single-threaded programming language. Did I put the definition here? Let's see. No, I did not write. Oh, I even typed the wrong here. This is the place where all the functions and variables are stored as a key pair value. Okay, and memory components is also known as variable environment. Code component, right? This is this place where the code is executed line by line. Code component is also known as thread of execution. So JavaScript is a single threaded programming language. Variable scoping, hoisting, closure, and how JavaScript manage memory during the execution context. Okay guys, let's continue here. It's not there, but it's okay. So now we understand the synchronous program, right? Synchronous means what? Top to bottom, line by line. But how we do the async program now? Asynchronous, right? So what is asynchronous now? Let's find the definition. What is asynchronous in JavaScript, right? Something like this, right? So asynchronous programming is the technique that enables your program to start a potentially long-running task. So any task which takes long time, right? Okay, let's go to the Mozilla Firefox here. I think this is okay, right? Asynchronous programming is a technique that enable your program to start a potentially long-running task and still be able to responsive to other event while that task runs, right? So this is the definition. I mean, you can check. So examples like fetching data, get user media, show open file picker, something, I mean, which takes long time, right? Something which gonna happens in the future. Basically time taking tasks, okay, time taking tasks. So that is asynchronous program, right? Asynchronous. So JavaScript is not a async programming language. It is not, okay? So that's why you have to create something, right, to make it asynchronous. And how we can do that? So let's write one function, right? SetTimeout. SetTimeout is a function, right? So it takes callback function, right? Okay. So you can say console log, right? And say, you can call it maybe, let's call it callback function from SetTimeout. See, this function, SetTimeout function takes callback function, that is the first thing, and the second one is timer, right? Timer. It has 5 millisecond, okay? So 5000 is 5 millisecond. Yes, you have to write it like this. No 500, no 5, no 5 second, no 10 second. 5000, right? 1000 is 1 millisecond. 2002, 10,000 is 10 millisecond. So just put it like this. So when this code run, what gonna happen? Anyone, what gonna happen here? Can you give me some idea what gonna happen? Yeah, go ahead.
The code will run after the timeout will run after 5 seconds.
5 millisecond. Yeah, that's true.
Yeah.
So fine, right? Let's. Okay, so let's run this code and try to understand this now. And exactly what happened, right? Let me prepare my board also. I think I will write something here. You know, my table is so small, right? I cannot move here, there. You know, I need to get like big working decks maybe in the future if I become rich, guys. I'm just kidding. Okay, so let's run this code now. Close here. So I'll refresh this. So we got event now, right? Event. So first we go to console, right? And let's restart. So start in, and after 5 milliseconds, 1, 2, 3, 4, 5. One, 2, 3, 4, 5, right? So see that? Okay, so you see, start in, so that is asynchronous program now already, right? Just happened in the in the future, like after some time, right? Okay, so how this happen now, I mean, it's still it's running, right? It's start, end, and then it just print this one. How that happened, that is the point to understand, right? Correct. So let's try to understand that. So now what happened, right? If we go to our writing pad here, so what you can think of, anyone? Let's start out. Let me create this. This is our call stack, correct? Call stack. Simple way, right? So we have what? We had this console log start. So let's say this is a console, right? This is the console. So you print start first, because when the global execution context enter inside here, right? Global execution context, and once it scans the whole program, it creates memory and all that done, right? Then what happened? Code start running. So it will print start. Then there was a start, right? It printed start, and then there is a set timeout now. Set timeout, right? So what is set timeout now? What is set timeout? This is the API of the browser. So there is set timeout. We can call it DOM API, right? DOM API. See, remember, browser has all this API, okay? And this comes with the power of the window object that comes from the browser, right? Browser give us what? Window, and it gives us a lot of power, okay? Local storage, right? And what else we can have? I think location. There is a lot of things, inside the browser window. So set timeout is the browser API. We call it API, right? API. So let's say we have this place where you store the function, right here. So what my function was? Set timeout. It has callback function, right? Callback. Let's say callback function. I did not give name or anything. We should have given the name to understand, right? Let's say this is callback function. So code will start running, right? It will print console log start, then end. It will print end, but before it print end, right? Remember, there was callback function. This will be sent here now. Callback function will be sent to the browser API, right? You just send here, and it attached the timer, right? Timer also of 5 milliseconds. So it's just waiting. The callback function is just waiting. Look at here. The callback function, this function, okay, this function is just sent to the browser API with 5000 millisecond timer, right? Timer, okay. So now it's just waiting. In the meantime, our code will continuously running, okay. Keep running. If there are millions of line of code, it will keep running, no stop, right? See, it did not disturb. You just go in the side to the API box and just waiting there. Fine. So now when the timer finish, right, what gonna happen? When this timer finish, it has to go somewhere, right? Somewhere. Where is that? So there, right? There is a callback queue now. There is something called callback queue, right? Callback queue. So this function will be pushed to the callback queue now. So this callback function came to the callback queue. Okay. So from here now, right? Who is responsible for sending this to the call stack? Because our code can only execute inside the call stack, no other place. So that's why there is an event loop now. Event loop, right? So what is the job of event loop? It will be continuously keep checking, right? Call stack. Job is to continuously monitor the call stack and callback queue box. So let's say call stack is done, every work is finished, it's empty now. So it will just grab this callback queue and send it here. Even this will be gone, right? There is no more this gone, okay? But when this finish, it will just push it here now, callback function, right? Okay, and then it will start. If this is a function, it has to create the execution context and all that. It will, after it will create everything and then do the job, right? Okay, then it will just print whatever it has to print in the console log. So there is a I think there was some simple console, right? That is what it's printing. It's just printing this, right? This is the line of code. Okay, that's the long thing happens. Okay, that is the set timeout, right? What if we have DOM API now, right? DOM API, like let's say, okay, let's create one DOM API also, right? So in here, I'm just gonna add simple. What we have a button. Let's add one button, right? And then click that button to do something. So let's say button, and click here, right? And let's give an ID equal to btn. Fine. This is in our document. So inside this function, right? I said document. So let's say let btn equal to document dot get element by ID, right? And you call the btn. We know that all. Fine. Now in this btn, right, you're going to attach the event handler. Btn dot attach, right? Attach what is that att? Oh, sorry, add event listener, add event listener. Okay, one second. I have to go. Okay, let's continue. So we have add a button, right? Add event listener. Here we attach the add event listener. So what is that? What it does, right? You can attach the event. So what kind of event we can do? Click, right? Let's add the click event. Click, okay. So we call it click event, correct? And oh my god, and then you can add callback function, right? So callback function, you can add it here or maybe create outside, does not matter, right? Why getting so much okay, fine. So I just added arrow function inside here, right? And I can do console.log I am from event listener, right? Event listener. Okay, simple enough. So when every time when you're gonna click the button, right, this function will be executed. So okay, so when the code run, what gonna happen to this function then? So this function is right now sitting somewhere in the browser API. It's just sitting there, right? So because we don't have names, so this is like an anonymous arrow function, right? Why not we just let's create this function with a name so it will be easy to understand, right? So I will say function. You can write just function, call it a handle click, right? Like that. And that function will be simple enough. That function, okay, function handle click, and then there is curly bracket, and you are printing this. So now handle click function will be sitting in somewhere. Let's make this short name, right? HC. So it will be easy for me to write. Okay, so now event listener. Okay, so let's go to the code now, right, and see how it works. So we have start, end, then that set timeout function will be running, correct? Done. But in the meantime, right, if I click this here, what gonna happen? See, so that function, the callback function, remember, handle click function, right, is sitting in the browser API, just waiting there, right? Someone might be click this button in the future, and then I will execute, right? So if every time I click, see, it's running, right? See, it's just running. Every time you click, it's running. So what happened now? How it run? Okay, let's write down here. So that HC handle click function, because in the somebody click, right, that function is already sitting here, right, in the API browser. It's there in the event, in somewhere in the event, right, event. Okay, so when somebody click that function, this function will move to the callback queue. Now it will just move. When somebody click, that function will move here, callback queue, and then our event loop, the manager, right, who is monitoring this callback queue and the call stack. Soon it finds the call stack empty, it will push this to the call stack, and then it will run. Simple enough. So that's how all the event function work. So function is same thing, right? When there is a function, it will gonna create, once it enter the call stack, then the same process apply. Okay, it will create the execution context. If it has variable and anything, it will be, you know, if there is closure, something, the same thing happens like other function. Okay, but it's just how it work, right? Okay, so next, and I think last one, let's look at the, because you have function now, right, for the fetch. Now here, if you are getting data from the promises, you know, how that is handled. Correct. So let's look at that one. So we're gonna create some simple example here. So let's go back. So let's say let's add it here, right? We have this, or maybe we just put here. So let's say function, right? Function get data. Okay, and we call it async. So let response, right, equal to await and fetch. Okay, so we're gonna add, okay, let's add some real fetch, right, some real data. So fake API product. Okay, we got that data. We just copy this and put it inside our code here. Okay, so this will return promise, right, and then you're gonna extract that data. So data will be from response convert into JSON file. Okay, and then console log dot data, console log, right, this data. Okay, console log data, right, but you have to now, right. Okay, let's do some magic, you know. Why not we can run this function when you click the button. So let's add another button here, right, or okay, let's do it here, you know, get data. Simple enough. So when this function run, and that is the promise, right, okay, you have to do here await also, await, right. Okay, and when this function run, right, this is a asynchronous program now. That means it is the part of browser API now, right? You have fetch function also, so this is, it is part of browser API. So this function, right, it will not work like normal function. So get data function will, what gonna happen now, right? So let's go here. So that is the get data function, right? Get data, that's the function. Okay, so that will be moved to our API now. This is the promise, right? This is a promise function. Okay, promise. So promise function, right, anything from promise, right, returning from promise has higher priority now.